Okay, so this paper had effectively 3 questions, as usual. Traversability question, minimum spanning tree question, shortest path question. You had to figure out which one was which. So on the introduction, it had all the questions listed, but it didn't say traversability question, for instance. So a map for people walking from the tourist information to all the other points. That there is just telling you to draw the network. Right, and I've done that already in the back before class, because you can all do that bit. The next question here says a tour map that enables people to visit all the points of interest, traveling along all the paths without repeating a path. Now, what does it mean to travel along all the paths without repeating a path? Yep, so that means all these arcs once and only once, and that's traversability. So to figure out if it's traversable or not, we have to first start by looking at the order of each of the nodes or vertices. So I'm going to put a little 3 next to that one because there's 1, 2, 3 paths that go away from that. There's 4 for this one, 3 here, 2 there, 3 there, 2, 2, 2, 2, 2, 2, 3, 2. I think that's all of them. So I've got 1, 2, 3, 4 odd numbers there. Okay, so the question is,
no, it's not.
This tour needs to start and end at the information office. So it needs to start and finish here. Can we do it?
No.
The answer is no. Why can we not do it?
Because there is it's more than 2 odd, even, odd, what? Uneven, something.
And the answer is no, because there's more than 2. Because there are, well, not more than 2 actually, there are 4 odd vertices. Now if we want to start and finish at the same place,
2 or 0.
only 0. If we want to start in one place and finish somewhere else, that's okay to have 2. But our question is, can we start and finish at the info office?
No.
So start and finish at the information office, we have to have 0 odd vertices. So if not, so there's our answer to the first bit. Investigate whether it's possible. No, because. All right, and if not, discuss what needs to change to make it possible. So we need to have 0 odd vertices. So one example of what can change is we can say we have to get rid of this path here and this path there. If we do that, then this becomes 2, this becomes 2, this becomes 2, and that becomes 2 because those 2 paths are gone. Now we've got 0 odd vertices. We can start and finish at the information center, and you could draw a list of the steps you need to take to get there, but we won't do it for this one because it's too long, takes too long to do. But by saying you could get rid of that path between Lookout and Sports Club, getting rid of New World to Statue, that makes every vertex even. Therefore you can start and finish at the information center would be a sufficient answer. Okay, it's also more than an achieved answer because it's asking you to prove that you understand what odd vertices do to a network. Okay, so the next question is a tour for segues to local interest points. Now, what they want you to do is put a path alongside an existing path so that you can get to every single point of interest. You don't have to be able to get there in one big circuit, but you have to be able to get to every single point. So what do you call a question that's asking you to get to every single point or vertex? Make a path that goes, maybe more than one path, that goes to every single point. If every single arc, going along every single arc is traversable, what does it mean to go to every single point? minimum spanning tree. So we're going to have to make a minimum spanning tree that goes along each of these, well, that goes to every single point. So to do that, we're going to use Prim's algorithm. Here's the word minimized, lets you know it's minimum spanning tree. So we're going to have to start from, well, it doesn't matter where you start from really when you use Prim's algorithm, but I'll start from the information center just because. So from the information center, I can choose 160 or 184. So what am I going to choose? Yes, so I'm going to say 160. Next, I'm going to choose 184 or 765. 184. Then 128 is my next one. Then 765. Then I can choose between these two. So I'll choose 584. Now I can choose between 896, 680, 1560 or 1352. I'll choose this one here. It's the shortest one available to me, and that's what Prim's algorithm tells me to always take. Shortest one that doesn't create a cycle. So the next shortest one is this one here, which is 80. Then I've got 280. Then my next shortest one is going to be this one here, which is 200. Then 440. Then what's next? My next shortest one will be, well, the red ones. So the next shortest one.
You already went there, so you don't need to.
The statue, I haven't been to the statue yet.
I can't see that part on the paper on the screen. Yeah, thanks.
Okay, the last one
960.
is this one that goes across to here. Now we have every single point on our tree. We don't want to include anything else because then we'll have a cycle or a circuit. So we have to add up all these numbers, and that total amount will be a distance which will minimize the cost of connecting all the different points. So if you add these numbers up, you can do that later. I don't want to do it right now. Do it right now? Okay. You're going to be in the video, okay?
Is it still on?
Oh my gosh, come
Right, so that gives you a total answer of 5,461 meters. If If you check this at home, check you got the same number. So that was the last question on this page. In here it also asked you to find the shortest route from the information office to a key point of interest. And I said the interest point was going to be the statue. So that's the, obviously that's the shortest path question. So how do we do this? The boxes, yes. Anyone remember what that's called?
Press something.
No. No. So to do this one, we're going to use what's called Dijkstra's.
Damn.
That's the one for the boxes, okay? So we have to start from here. You have to draw a box at every. Do you know any other ones?
No.
Me either. Right, we're going to do all these boxes. Now remember, The one you get in the test will not be as kind of obvious as this one, and you have to do all the boxes to prove you found the best one. You might guess it. If you guess it, that's only an achieved.
So we have to do the boxes everywhere.
Yeah, doing the boxes shows that you've done it properly. Okay, I'll do this one in the black pen. So, where are we starting from? So that's going to be point number 1. How far is it to the info center? Well, that's where we're starting, so it's 0. So now we're going to pick the shortest one next. That's going to be, well, we're going to label them all first. 160 and 184. Okay, I should draw that 184. Next we pick the shortest one out of those two. So we've done those two lines. That's going to be this one. So stop number 2 is going to be 160. Then we have to move from there to here. So 160 plus 765. Upper. 160 plus 765 is. See if you're paying attention.
You just embarrassed me on the video. Start again.
925.
That's upper. So no one knows what your real name is. So 925. So number 3 stop was going to be this one because it's the shortest. 184. Then we're going to add on from 184 to 128. That's going to give us 312. That's going to make it the next shortest one.